Hi.
Did you know that some viruses or bacteria can live up to 2 hours or even longer on surfaces like doorknobs or handles? When a person with a germ touches a doorknob, they leave some of it behind. A person who follows may pick up these germs. Free-living germs like bacteria and fungi can survive on inanimate objects longer than viruses. A great need for antibacterial viral surfaces exists, so as to reduce the spread of diseases. SelfClean, a project conducted within the European 7th Research Framework Programme, is considered to be one of the major advancements on this specific research field. Following the traces of the story, we found out that the coordinator of this project is the National Technical University of Athens, Greece. On our visit there, we met with Associate Professor Dr. Pavlatou, who explained to us the idea behind the project and its scientific challenges.
The aim of the SelfClean project is to produce composite coatings that present an antibacterial and photocatalytic behavior under UV and daylight irradiation.
9 partners from 4 different European countries are directly involved in this project.
The partners that they are involved in this SelfClean project are SMEs like Nadico, which is actually the partner who is responsible for the production of the produced nanopowder, titanium oxide nanopowder, as well as Elplatec, who is responsible for the electrolytic bath, since the coatings are produced by electrodeposition, and third, Campacas, which is the partner who is producing the metallic articles.
While the consortium's SMEs set the needs and requirements of the project, 5 research and technology developers had to deliver according to these requirements. SP, Technical Research Institute of Sweden, Jönköping University, IPU, CERT, the Center of Research and Technology Hellas, and the National Technical University of Athens.
The main challenging of a SelfClean project are first to produce titanium oxide nanopowders that they are doped and that they exhibit photocatalytic and antibacterial activity under UV and daylight radiation. Secondly, is to produce the composite metallic coatings in which titanium oxide particles are embedded in these metallic surfaces. And third, to apply this coating on the everyday touch surfaces like knobs and tabs, which are the methods that we are using. In order to produce titanium oxide particles, we apply a salt gel process, and in order to apply and to produce the metallic coatings, we apply the electrodeposition process.
Titanium oxide particles were produced using the salt gel method. Salt gel technology includes the following basic stages. First, the titanium precursor is hydrolyzed in an aqueous solution and forms a colloidal suspension, the sol, which gradually, through condensation reactions, forms a continuous solid network, the gel. In order to synthesize doped titanium particles, the appropriate dopant source is added. The amorphous doped titanium powder, obtained at the previous stage, is calcinated at increased temperatures for dehydration of the gel and the simultaneous removal of volatile organics. Finally, the final product is milled in a mortar to obtain a fine and homogeneous titanium powder. A small portion of a powder suspension is transferred into an appropriately designed glassware, followed by introduction of the model pollutant tested. The system is placed in a photoreactor where it is constantly irradiated by a light system in order for the possible photocatalytic degradation ability of the titanium particles to be activated. The first step of the electroplating process is the thorough check of the electrolytic bath. Appropriate measurements are carried out in order to control the concentration of all chemical compounds in the bath. After the appropriate control, the bath is imposed in ultrasonication so as to achieve the desired dispersion of the titanium oxide nanoparticles in the electrolyte. Along with the preparation of the bath, the metal articles that will be plated are imposed into the pre-treatment process. This process comprises degreasing, rinsing, application of a first thin layer of nickel coating. The final step is the application of the SelfClean coating in the metal article. The electrolytic parameters are set in the pulse current rectifier via appropriate software. The metal article is immersed in the electrolytic bath and the current is imposed. At the end of the plating, the metal article is covered by the new SelfClean coating. The final coating of the metal articles does not only provide the antibacterial and self-cleaning properties, but also a high aesthetics finishing in order to be adopted by the market. The metal articles are now ready to be tested in the real environment. Metropolitan Hospital has shown explicit interest in the results of the project. The institution represents a potential large customer for the self-cleaning antibacterial products. There we spoke with Dr. George Panayotopoulos, who is in charge of the anti-infection office of the hospital.
As you probably know, because this is quite widely known in the community and in the press, all tertiary hospitals like ours are plagued by nosocomial infections, and we also call them hospital-acquired infections. Those bad bugs are transmitted within hospitals through surfaces, through devices, through objects, through the hands of the staff, and these are quite bad bugs because they are resistant to antibiotics. And particularly in Greece, we have overused and malused antibiotics, so our strains are quite resistant to most of the antibiotics. Multi-resistant strains, we call them, and they are the cause of quite serious and quite hazardous for the patient nosocomial infections. Of course, we do our best. We use antiseptic solutions, we use antibiotics, newer and newer antibiotics, and we are trying our best to fight off those infections. But if we had a new substance, a new surface, a new weapon to fight them off, that would be fantastic. Our hopes and our expectations have been invested in this project because we strongly believe that with those new materials we would be able to reduce the rate of nosocomial infections, and if we manage to reduce them, then we will also reduce the mortality of those infections within hospitals. So this could be a strong advantage for the patients, firstly, for the doctors, for the hospitals, and mostly for the health system, because the health system consumes a lot of resources in the war against those infections that we call them nosocomial infections, and which are a main target for us infectious diseases doctors. This is the intensive care unit where the danger of nosocomial infections is as high as possible, and this is the main site of the hospital that we are trying hard to fight these infections off and to eradicate actually the bad bugs, the pathogens from the surfaces and from the environment.
Handles, doorknobs and other metal articles were placed in various places of the hospital, such as the ICU, offices, patient rooms, storage rooms and toilets. Two tests were mainly used for investigating the efficiency of the antibacterial coatings. ATP test is a fast test that is based on measurement of the energy cells of the bacteria. Contact plate tests are more accurate. After collecting the bacteria from a surface via a plate containing agar, the plates are placed in an incubator at 37 degrees Celsius, and 2 days later the bacterial colonies are measured. We were fascinated to find that the technology under investigation combines strong scientific evidence leading to positive results with clear ways that the technology can be applied in everyday life. The SelfClean technology is a breakthrough concept by itself. Considering the added value it can offer to the society, the impact can be huge.